guys, my name is Jason with Mount Baker Mining and Metals, and I am so excited because we have a new product I want to share with you today. We have a dual shaft shredder, and we're going to take some of these boards in this computer tower and we're going to run it through the shredder and reduce it in size. In the past, what we've done with this stuff is we've thrown it right into our hammer mill and onto our shaker table to separate the precious metals and the other goodies that are in these boards. But by using a shredder to pre-shred the material, get it smaller in size, we can increase the efficiency of the whole process, reduce the wear in the hammer mill, and get more boards through the system faster so we can get more precious metals and more base metals. This worked so well. I am so pleased with these results. I couldn't have asked for a better shred than this. This will go right into the hammer mill. It will greatly reduce the work the hammer mill has to do. I'm thinking too, if you're maybe not in the PCB recycling industry, but you have other bulky items that need to be shredded or reduced in volume, it reduced these boards by up to 80%. So if you have bulky buckets or plastic jugs or fiberglass or anything that needs to be shredded or chipped, give us a call. These things are so awesome. But now let's try running this tower through and see if we can get this tower chipped up into small pieces as well. So it took a couple times for the shredder to pull that tower in. It hit its load limit and then reversed. But after 3 or 4 times, it just sucked the whole thing through and shredded it up. I think it worked great. You've got boards, you got steel, you can further process this. I am just so happy with these shredders. So I don't have a PCB system set up right now, but I want to take some old footage from one of our previous videos and put it right after this so you can see the whole process from shredding boards all the way to getting the precious metals off the shaker table. We're going to be running some printed circuit boards through our turnkey PCB system behind us here. So we've got several different samples to run today. So this will be the first sample, and these are shredded up boards, but look at all the gold fingers on them and little gold foil. Then we have a sample of these connector pins here. I think these are called flat packs. We got some of these as well, so we'll run these as its own little sample. And then the last sample is in this barrel, and I'm not going to stick my hand in here without gloves, but this is shredded up, I think he said lithium-ion batteries. And this is, there's copper and aluminum, and there's a little bit of steel in here. It actually looks like quite a bit of steel. But if you get up close, he says there's also some black metallic powder in here that I think we can recover on our shaker table. We'll take a little walk through our system here. This is what we call our small turnkey PCB system. This is a 16-inch by 12-inch hammer mill. It's got a rotor on this shaft here that spins around in this case. A bunch of hammers attached to the rotor, and they just beat anything that goes down the chute here. Beat it up. There's a screen that goes all the way 180 degrees along the bottom of the mill here. And this screen has 1.2 millimeter slots that are about 1 inch long. And the whole screen's covered in those. And then it comes down this chute onto one of our 4-foot by 8-foot shaker tables. Everything that's light, a lot of this stuff will float in water, but light, fiberglass, plastic, anything that's has a density of about 3 grams per cubic centimeter or less will come down here into the number 4, the waste trough. The metals that are heavier, but still not heavy enough to get up the ramp here, aluminum is a good example, will come down right here at the base of the ramp and into the number 3 middlings port. I'll get a bucket under there to catch those. And then all your copper, your steel, anything denser than about 5 grams per cubic centimeter. There's a little ramp built in the table. You can see these 4 long grooves. Those metals will come up the ramp under this diagonal water bar onto what we call the cleaning plane. There's another little flat spot up there. And they will come down into the number 1 and the number 2 high-grade concentrates. And you'll see a little bit cleaner, higher grade stuff come down in the number 1. More of the dense stuff will come down here. If there's a huge volume of copper or steel, a lot of it will go into the number 2. We have our 2 safety grooves here in the table that catch anything that kind of overflows down here. It'll bring it over to the number 2. But almost all the copper and the gold and the dense metals will come down here. We recirculate all the water through the system again. We have 2 pumps. There's a 3-phase pump here that pumps a large volume of water up into the back of the hammer mill here. And that helps the crushing and the stuff that flows down onto the table. We have another pump over here that feeds the water bars to the shaker table. So we'll get this thing fired up and we'll see what we can do with these samples. So here's our number 1 bucket. There's the metal fraction, the number 1 fraction. And a lot of that stuff is copper. And then those gold, I don't know if they're gold foil or gold plated something. But that is where all the good stuff is. So there's number 1. This is the number 2. But it's still almost all metal. There's a few little pieces of fiberglass, green board that probably have copper still laminated to them. But I mean, that's, you know, looking at it, that's 98, 99% metal there with just a little bit of contamination in it. And our number 3, oh, let's see, this is mostly that green board. I don't see any copper at all. There's a few little silvery flakes that are probably aluminum. But this is where the junk went. And I took a sample of number 4 there, and it was just dust. I mean, it was just super, super fine, kind of like this gray stuff here. It's just little bit of sludge coming out of number 4. So most of the waste in this sample went to the number 3. Okay, one more quick look here. This is the number 1. I think it's a little easier to see through the bag rather than in my hand. A bunch of pins, little rolled up pieces of copper. There's a bunch of that flake, that gold flake and stuff. So there's number 1. Here's an up close look at number 2. A little more aluminum or silvery colored metal in there. The copper pieces are finer. There's a little bit of glass and green board in there. There's a piece of green board with copper around the edge. So that's the number 2. And then here is the number 3. And like I say, I don't see any copper. That might be a little piece there with some green board on it. Black plastic stuff. A lot of green fiberglass. I don't know. You see any copper in there? I don't see hardly anything. Wait, what was that? There's a little piece maybe. But, I mean, hugely, hugely clean. 99.99% clean copper and 98% metal and, 100% metal, 99.9. So between just those 3 fractions, 1 and 2, got almost all the metal, and number 3 got almost all the waste and hardly any metal. So there you go. There's 1, 2, and 3 from that first sample we ran. So here's something pretty cool with those black flat packs. All this stuff right in here is gold. And there's a gold line all the way down the edge of the stuff there going into the number one. So that's a pretty nice little band of gold. But it's super, super, super fine. Very, very small. So there you go. I got some gold out of those black flat packs. Well, I'll get the table kind of brushed down and get all the stuff into the number one and number two down there, and we'll take a look. There's that gold line coming down the table right into number one. Here's our flat pack results. We'll take a look at our number one here first. It looks like a lot of those pins came through into the number one. And it also looks like they're maybe copper pins coated with that silver stuff. Here's the number two. There's a little bit of that black stuff that got into the number two here, but a lot of copper. It's still pretty heavy and dense, and it looks like a little more of that silver colored metal or that gray colored metal made it down in here. So that's number two. And then this is the number three. Again, just like on the previous sample, almost all the waste went into the number three. But looking up close, you can see very little metal in there. So there you go. There's flat packs 1, 2, and 3. Okay, next we'll try these little plugs and pin holder things. Plugs number one is almost all pins. You can see there, they all came over into number one. Most of them are still whole. Here's number two. Some pins and little pieces of wire and stuff. And a little bit of that thermoplastic, black plastic got in there. But what I noticed is while I was letting the table clean itself off, as the copper ran out, some of this thermoplastic started filling up the safety grooves and coming over. So I think that's where most of the contamination came in this one, is I just let it run too long without enough copper on it to kick the plastic out of the safety grooves. And then here's the number three. And there again, I don't see any copper. It's pretty much straight plastic. And here's our results from the boards. So this is the number one fraction, tons of pins, big pieces of copper. And over here in number two, not as many big pins and stuff, mostly copper flakes. I think that's from lamination copper between the boards. And then here's the number three fraction. Oh, that's on the surface. But yeah, there's, I don't know. You guys see any metal in there? So it does a darn good job of separating the metals from plastic and fiberglass. So you can take whole boards, run them through the system, get pretty much all the values here and all the waste here. So here's that battery sample. And I wasn't going to run it through a 1.2 millimeter screen. I was actually going to change it to a quarter round hole. But then I got to looking at it, and the steel fraction in here, let's see if I can get a piece. The steel fraction in here is just super thin little foil stuff. And so I'm going to try I don't know, half a bucket or 25 pounds or something through the screen we got in there. See if we can separate this plastic and the junk. This is going to be an interesting one. I've never dealt with batteries before, and I think if I can get this to work, you could probably just hang a magnet over the high grade end of the table and pull all the steel off as it comes out. Because you can see there, like there's a lot of copper in there, and whatever that black stuff is, if it's dense enough to come across, we should be able to grab that too. Well, we got done running the batteries, and I don't know if it went good or not so good. Here's a little snapshot with the table off. And this lighter colored stuff, I think, is actually aluminum. So if you saw it on the video, there was a band of aluminum coming down, and then there was a band of this copper, little copper flakes and black stuff. I don't know what the black stuff was. And then over here, there was, clean copper coming down. And so I think in number 1 and number 2 is where the copper and most of the black stuff went. Number 3, I think, caught a little bit of copper and all the aluminum. So we'll see how that goes. But if you could get it feeding really consistent through the hammer mill, you could put a splitter right here in the number 3 and divert the aluminum one way and the copper and the black stuff another way. But I'm just not familiar enough with batteries to know if you want the black stuff in with the copper, the aluminum in with the copper, or what. So this is the number 1, and a lot of the bigger pieces of copper went in here. There's still quite a few pins. I think there was some contamination with the boards that we ran earlier. But any of the larger pieces of copper, steel from the batteries probably went in the number 1 port on the table. Here's the number 2, and there's some copper flakes and stuff in here, and a lot of this black stuff. This is like the bigger pieces of the black powder in those batteries. Again, I have no idea what that is. A little bit of contamination with fiberglass and a little bit of plastic in there, but this is mostly copper and the black stuff. And then this is the number 3. There's a little bit of copper in here, a lot of aluminum, and a lot of that black stuff. And so I was mentioning earlier where you could set it up to where you could have a splitter on that tailings trough, or the number 3 trough, and you could split the aluminum to go one way and the copper to go another. So I think you could clean this up even further. The interesting thing about that battery sample was when I would put handfuls of stuff in, black water, it just turned super black, and it'd come down, whichever way down is, into the number 4 port down here. And it just run down the table like it was, so fine that it couldn't settle out in the grooves. But whatever was large enough, it ran its way over into the to the ramp here and came down that way into the number 3 port. Change the screen and make a little bit bigger screen, like a 1/4 inch hole, and try that and see if that helps separating the aluminum and the copper and the steel a little bit better. This is some stuff that we ran through our PCB turnkey system, ground up a bunch of motherboards and junk. But let's get started. We'll mix up some of this and some sulfur in a crucible, and we'll get it smelting and see what happens. I've got 200 grams of the number 1, and I'm going to use the sulfur. I found at the hardware store it's like 90% sulfur. All right, we're all mixed up in our crucible. All right, guys, here's our second one with the 10 grams of sulfur. There we go. Slag looks good. Let's break it up, see what we can get. Nice copper cone. All metal. It poured just perfect. Let me grind a surface on this and get it XRF'd and see what we got here. Here's the XRF for our metallic block from our second smelt. All right, guys, so that turned out actually pretty cool. A little bit of sulfur, so about 5% by weight. Looks like it eats up almost all the iron, and it allows for a really, really nice pour. Our metal block is copper and tin. It's about 95% copper and tin, which is like a bronze, I think, is essentially what bronze is. And actually what I might do is take these 2 trays here behind me and pour them into ingots or bars or plates. And then we can start looking at electrowinning away the copper and dealing with the anode slime. Stay tuned for more videos on this. I'm pretty excited about where we're going. If you have any questions or comments or advice for me on this process, please leave me a comment in the description below. Otherwise, thanks for watching, and we'll see you on the next video.